Alright, afternoon all. Today we're doing the last bit of new stuff. And I say new with a bit of caution because you're going to find it very easy and it won't feel new. It'll feel sort of a reminder of stuff, which is good. And then I'll give you more of an outline of what's in the topic and next steps. And then the rest of this week will be doing some topic, but then also setting you up with enough so that you can do your draft of your investigation as well. And so you can do some of that while on work experience. Alright, so with this, we've seen the general form of a sine function before. We know that the value up front controls how big it is. This controls how often it repeats. This is horizontal translation, vertical translation. And then we can use this to model scenarios. So, the height of the tide above mean sea level on the 24th of January in Cape Town is modelled by this function where t is the number of hours after midnight. So we can grab our calculator and draw this function for the 24 hours after midnight. Oh no. This is great. Turns out my license is expired. I will renew that. But for now, we're doing this on Desmos. Alright, what you should be looking at, if you change your view window from 0 to 24, and I would change your Y view window from -4 to 4. The reason is because the 3 at the front of the sign means this graph is going to be 3 high, and because you want to see it with a bit of space, you can make it from 4 to -4. If you press Shift View Window on your calculator, it will change the thing that you can view. Lots of these modelling questions come from using the calculator as well. The question asks, when is high tide and what is the maximum height? So it's asking, when does that occur and when does this occur and at what height is it at that point? If you in your calculator hit gsolve max, it will automatically find that high tide point, which should be about 3.3 for the first one, if I'm reading my screen right. So you hit gsolve max, and then if you hit the toggle across button, it will move across until it finds the first solution after that, which on the graph looks about the point 93. Is that about right? Beautiful. Alright, so there are two high tides. Makes some sense. What is the height of the tide at 2 p.m.? So 2 p.m. is 1400 hours, because you're going 14 after midnight. It's about there on my graph. For you, you want to calculate a y value, because you're not sure what the y value is. So you want to press gsolve, and then arrow across, so F6, to go across, and then you want to find ycalc. And when you press ycalc, it'll say, okay, cool, give me an x value and I'll calculate the y value for you. You put in x equals 14, and it will spit out the y value for you. Beautiful. Beautiful. So this is a little about, yes, good, navigating your calculator. Alright, so then we've got the answer to B and C. D. D reads, a ship can cross the harbour provided the tide is at least 2 metres above mean sea level. When is crossing possible? Or if you're the Mexican Navy, you can pass under the bridge when the height is below some sea level. You want to see the news on the weekend? Yeah, how awkward. You ran into the Brooklyn Bridge. So, in this case here, we know that we can get into the harbour when we're at least 2 metres above sea level. And we're asking for how long or what periods of time can we enter the harbour. The best way to do this is to put in the line y equals 2. So, go into your calculator and as a second function down, put y equals 2 and graph a line at the height of 2. Then you should be looking at an image something like mine, and you're really wanting the times where these occur. So you're going to hit gsolve intersect and find where that meets. And you should be able to tell me that it can cross between like... Actually, what is that first point?
1:39.
Yeah. Now, is that 1:39 AM? There's a trap built in here. 1.39 is 1.39 hours after midnight. But 1.39 hours after midnight is not the same as 1:39. If that makes sense? 0.39 of an hour is 0.39 times 60 minutes. Because if you think about it, 0.5 of an hour would be 0.5 times 60 is 30 minutes. 0.39 of an hour is like 23 point something minutes. I can't do it in my head. So really, if you wrote this as the time, your answer would be wrong. Your real answer should be 1:23 AM. So just be 24?
23.4.
Cool. I didn't know what it was there. 23.4. Honestly, 1:23 AM would still be about right. So just be mindful that the decimals here aren't neatly packaged up as hours. 1.39 is the same as 1:23 AM. Yeah, so it's an easy trap to lose a mark. Alrighty. What I'd like to work on today is a few questions from cosine graphs. Don't do them all, and use your calculator heavily. They are exactly the same as the sine ones we did last week in terms of translations moving around. Then look at trig modelling, which is similar to our tide question that we just looked at. 4 questions there. And have a very quick go of tan, which is these 3. And then the topic's done. In the SAT, there'll be chapter 5, which will be arc length and the start of the unit circle. And then chapter 7, which is trig graphs and trig equations, so solve a trig equation. We're skipping G. And note, chapter 6, the one in between those two, chapter 6 covers sine, cosine rule, etc. It's not going to be in the SAT. In the past it has been. So there are some old SATs on Canvas where you'll see sine and cosine rule. And you'll have seen them last year when you did year 10 maths, the non-right angled trig, but they're not in the SAT. What we will do in the brief gap between SAT and exam, we'll have a quick reminder of what sine and cosine rule will be, and they'll pop up in the exam, but your exam won't count for SACE grades. Don't stress chapter 6 before the SAT, it's chapters 5 and 7, and not even all of 7. Does that sort of make some sense? I'll type up a bit of a better summary and send it to you on Canvas, but today you're looking at graphing some cosine curves, and then most importantly, modelling trig, and it's very calculator heavy. The modelling is done using technology. SACE is within the course knowing that you have technology in mind, in hand, if that makes sense. Alrighty, go.